we're going to talk about vectors that are neither parallel nor perpendicular, right? So here are just two random vectors. How can we add those two vectors together to find their result? We got two ways of doing so: graphically and algebraically. Now I'm going to show you quickly how to do it graphically, just so you kind of have the idea, but it's kind of long and complicated, so we're going to use mostly or almost always algebraically. So to do it graphically, you need a protractor and a ruler, and you actually draw everything exactly to scale. Right? So here I've got this vector, which is 4 units at 26 degrees. So if I bring my protractor over here, right, I got 4 units at 26 degrees, and it's a lot harder to do on a smartboard than it is on a piece of paper. Right, and this guy is 8 units at 0 degrees. So to do it graphically, we're going to use the head to tail method. We're going to draw vector number 1 to scale. We're going to draw vector number 2 with the tail of vector number 2 at the head of vector number 1. So there we go. And then my resultant vector, just like it was when they were perpendicular, goes from the start of vector 1, or the tail of vector 1, to the head of the last vector, in this case vector number 2. To find the resultant, we have to measure it. So I pull up my ruler, which isn't quite long enough. So let me make a little mark here. That's 10. And how much more do I have? 11.6. So my resultant vector, when I measured it, was 11.6 our famed FB units. And I measure the angle. Come on, protractor, come on over here. And I measure the angle at, looks like 8 degrees. Yeah. So if you've got a nice big piece of paper and you can do everything, you know, I had these vectors pre-made, so it was pretty quick. Not too bad. You get more than 2 vectors, it becomes a little bit messy. And then again, it depends on how accurate you draw them, how accurate you measure. So a lot of stuff depends upon your accuracy. So we are going to mostly use and concentrate on finding the resultants algebraically. I'm going to show you the list of steps, and we'll break it down each step with an example. Now, all of these things we have already done. So it's taking everything we've done, putting it all together to use it in this solving for vectors algebraically. Okay, so draw a diagram, which we would do anyway. Break each vector into its x and y components, right? We did component vectors beginning of last week, using the x component as magnitude times the cosine, and the y component as the magnitude times the sine. So we've already done breaking vectors in their components. Since the x components are parallel and the y components are parallel, we're going to add the x components and the y components to get this little e guy here for, right, these two little e's. That's just summation notation. That means I'm going to add up all the x components and I'm going to add up all the y components. I can because they're running parallel to each other. We've already done that. Then we're going to find the magnitude of the resultant, because now we've got two vectors, one in the x direction, one in the y direction, that are perpendicular to each other. So I'm going to use the Pythagorean theorem. Right? The resultant vector squared is the x component squared plus the y component squared. And then I'm going to find the direction using the inverse tangent, which would be the total y over the total x. And then check its quadrant, depending upon whether the x's are positive or negative, and the same with the y's. So you want to screenshot that real quick or get that down. I'm going to go through each one of these steps individually with an example so that we can follow along. Okay? So, here we go. Number one. So I just picked two random vectors. 15 newtons at 30 degrees and 60 newtons at 200 degrees. So step one, I'm going to draw a diagram. So again, I'm just going to estimate that that's about 30 degrees. So there's vector A. Vector B, 200 degrees is, and it's going to be about 4 times as long. So I'm going to put it about here. 1, 2, 3, maybe a little longer. Okay, again, it's just a rough diagram to get us an example. Get us in the ballpark. And then my resultant vector is going to be here. Okay, so that's my diagram. I would also suggest that you make this little table. It's going to help you keep things much more organized and much more together. I'm just grouping this so I can take it with me. All right? So, step one, make a diagram, and make this little table. Step two, was break each vector into its x and y components using the sine and the cosine. Ooh, I don't have my calculator up. Okay, so for vector A, it's going to be x component equals 15 times the cosine of 30, and the y component is going to be 15 times the sine of 30. So if you had your calculator, you're going to do 15 times the cosine of 30, 12.99. And then I'm going to do 15 times the sine of 30, or 7.5. I'm going to do the same for vector B. Vector B is going to be x component equals 60 times the cosine of 200, and y is going to be 60 times the sine of 200. Both of those should be negative, right? Because I get a third quadrant, negative x, negative y. Okay, so let's just see. So I have 60 cosine 200 negative 56.38 and 60 sine 200 negative 20.52. I'm going to take these answers and put them into my chart. Okay? So drew my picture, broke each vector into its components, put those components into my table. Step 3. Yeah, let me take all this with me, right? So we'll keep everything together, group it all together. Copy, come on over here. All right, so I have everything together. So step 3, find the total x and the total y. That's pretty simple. I'm going to put down here a total, which is why I made an extra column in my chart to begin with. And I add up the x components. Right, so here's my total x, negative 43.39. And I add up my total y, negative 13.20. Just simply add them together. I can add them together because they're in the same direction. Right? Add them together because they're in the same direction. So that's a pretty quick step. Next step says find the resultant magnitude using r squared. And so here's my r squared, so r is down here. So I'm going to say r squared equals total x squared plus total y squared. My total x is a negative 43.39 squared. My total y, negative 13.02 squared, right? Because the x components and the y components are perpendicular, just like we did the other day or on Friday, Thursday and Friday. I can use the Pythagorean theorem to find that total. So I get 43, negative 43.39 squared plus 13.02 squared gives me r squared equal to 2052.2125. So I'm going to take the square root of that and get a magnitude of 45.31. Okay, that's my magnitude. 45.31 newtons. So let me add that to my drawing here. Put that stuff together. Copy it. So the next step is to find the angle. And so I'm looking at this angle right here. That's the angle I'm looking for. So I'm going to find the angle using the inverse tangent, which we did, again, when we were looking at perpendicular components. Okay, so theta is equal to the tangent inverse of total y, right? It's always the opposite side over the adjacent side. Total y over total x. I'm going to say the tangent inverse of negative 13.02 over negative 43.39. Now I need to take an inverse tangent, second inverse tangent of negative 13.02 divided by negative 43.39, which is going to give me a theta of 16.70. Now, this is where the tricky part comes in, because you have to check and remember that the calculator has no idea what quadrant we're in. Okay, that's why you need to check what your total x and your total y are. In this case, they're both negatives. Right? So negative x, negative y puts me in the third quadrant, which means the angle has to be between 180 and 270. So the calculator is telling me it's 16.7 degrees into the third quadrant. So I'm going to need to add 180 to that because I'm in the third quadrant. If I was in the second quadrant, this would be a negative number, and it would be 180 minus that number. If I was in the fourth quadrant, I'd have to subtract whatever I got from 360. In the first quadrant, it's just the angle. So the total here is 197? No, 194. Sorry, 194. 204. Monday morning math. 196.7. Okay, I'm thinking right. 196.70 degrees. So my final answer for the resultant vector, remember, it's got to have two parts, a magnitude and a direction. So the magnitude is 45.31 at 196.70 degrees. Okay, so I know that was pretty fast and went through that quickly, but I wanted to get you all the steps and let you see it so that we can work on it from there. I'll have to do a little pause on my recording.